So today we'll be seeing the topic called fuel injection systems for a diesel engine. So this is lecture number 9 in mode, and the various components of the fuel injection systems. We have different components, and we need to understand the importance of various components of fuel injection system, which integrates the fuel tank, fuel filter, also fuel lift pump, fuel injection pump, injector. We have low pressure, high pressure links. Even we have seen the same thing yesterday also. The difference between the yesterday class and today class, except few change with respect to the types of injection. Yesterday we have seen multi-point fuel system, so today we will be seeing a common type direct injection system. It's also similar to MPFI, and the fuel injection what we are using, it's having different type of nozzles. So we will see that one. Okay. And how the fuel injection and spray characteristics is going to play a vital role with respect to the different parameters that we will see today, and the injection timing, and how this will influence the emissions also we will see, and what is called phasing of injectors. So we will see all these topics today. And the most important thing with respect to the injection system is the multiple injection strategies. What we have covered, even I have covered that what multiple injection strategies in the emission control technologies, basically exhaust gas after treatment I have given. So you need to look for multiple injection strategies to reduce the emission. Even that I will cover it today. Even though I have covered that during my previous classes when I am taking with respect to the emission limits and also the exhaust gas after treatment. Okay. So with respect to the diesel engines, you have the injectors, and again we have seen the 4 strokes: intake stroke, compression stroke, power stroke, and exhaust stroke. Here, with respect to diesel engine, what is important is the diesel compression going to occur when fuel is injected into the hot, highly compressed air in the cylinder. And again, you see here the compression ratio of diesel is higher than petrol, having 16:1. It can even be higher than this also. And here, in the case of a diesel engine, the incoming air is compressed until it reaches the temperature of 540 degrees Celsius or 1000 degree Fahrenheit. And here we follow the compression heat. And we have seen the 4-stroke, where first stroke the piston moves from TDC to PDC, which is nothing but the intake stroke. And the next stroke is the compression stroke, where the piston moves from PDC to DDC. As the piston reaches the top of its compression stroke, means the second stroke, top of the compression stroke is nothing but the piston moves from PDC to DDC. And before it reaches the top, which means before the piston reaches the top dead center, the fuel is injected to the cylinder, where it is ignited by the hot air, and you get the injection. So we have seen this even in the valve timing diagram also. And again, in the valve timing diagram, the fuel gets injected, the fuel valve opens. When the fuel valve opens, you get the injection. That will happen either 15 degree or 20 degree with respect to the speed and different configuration of the engine. It can be even a 2-stroke or 4-stroke. Okay. So again, with respect to the method of injection, it can be 2 methods. One is indirect method, and another one is direct injection method. Even we have seen this in even yesterday class also. The GDA, where it will be directly injected to the combustion chamber, and we have seen the single point fuel injection, multi-point fuel injection. So similar to that, in the diesel engine we have indirect injection and also the direct injection. This is the typical layout of an indirect injection in a diesel engine. It uses a pre-chamber. This is the pre-chamber, and again the glow plug. So we will see about the glow plug. What is the glow plug? Basically, glow plug is a heating element. It will heat the fuel, and and you see here in the case of indirect injection system, also called as IDI, the fuel is injected into a small chamber, basically pre-chamber. This is the pre-chamber where the fuel gets injected. It's not directly injected into the piston combustion chamber. So the portion above the piston is called a combustion chamber. Instead of you directly injecting below or above the combustion chamber, you are going to inject in a place called a pre-chamber place, which is connected to the cylinder. It is connected to the cylinder. You have the opening here, and what happens here is you have the air and also the fuel where it gets uh, mixed, and you get a combustion here. Okay, the initial level of combustion will happen here also. Okay, and the advantage here is it has the effect of showing the rate of heat release. Okay, higher the heat release, and again the noise what you are going to get will be lesser, because you see here if you directly the combustion is going to happen directly above the piston or in the combustion chamber, there is a possibility the noise is going to be higher. Okay? And if suppose if the combustion is going to happen at the first stage, and then the same combustion whatever you get it's coming passing through this opening, and again the final combustion if it is going to happen about the piston and in the combustion chamber, then you tend to have less noise. Okay, that's it's also one of the advantage that you have, because the, the pressure and the temperature is going to be higher, and that will cause higher noise because of a diesel. What's the main purpose of a glow plug? We'll see. I told you the glow plug is it's a heating element basically. It uses the 12 volts from the battery. It is basically the electrical and electronic system the glow plug contains, and it aids in starting of a cold engine. When the temperature is less in the engine, when the engine is in cold condition, uh, it is will heat the fuel using the 12 volt from the battery, and this is mainly used for a cold starting condition, and is always used in diesel engine because equipped with a pre-combustion chamber, and it can also be used in direct injection also. What we have seen is an indirect injection. Even this can be used in direct injection, which will help for starting the engine. So here we have seen because of this heating, the temperature is going to get higher because of this glow plug, and when the temperature of the glow plug gets increased, the resistance uh, is also going to be higher. See, you know the formula V is equal to IR. The voltage is directly proportional to current and the resistance. So when the temperature is higher, which means that when the current is higher, the voltage is also going to be higher, which means the resistance what you have for the heating element, basically the glow plug is also going to be higher, and this by the way you get the heating done with the help of the glow plug, which increases the temperature of the fuel. This is the typical glow plug line diagram. Um, that is used in a diesel engine. Comprises of a 12 volt battery system, and it's basically electronically controlled, computer operated, electronically controlled glow plug. It's having the relay, it's having the battery, and will also heat, preheat and heat the air, and it will give a signal accordingly. It will heat incoming air into the pre-combustion chamber. The number of glow plugs in an engine depends on the engine configuration. So typically each cylinder can have one glow plug, or depending upon the configuration of the engine what you have. Accordingly, the number of glow plugs can also be higher. So in the next injection is a direct injection. So in the case of direct injection diesel engine, it injects the fuel directly to the combustion chamber. It will not. In the case of indirect, what you have seen, we use the pre-combustion chamber, but here uh, we directly put it into the combustion chamber. But here, in the case of direct injection, sometimes we are not going with glow plug. Okay, many designs do not use a glow plug. Okay. And again, the injection pressure is going to be higher in the case of direct injection engine. With respect to the different components that we have for a fuel injection system, you have the fuel tank and the fuel pump. A fuel tank is basically, it is differ from that of a gasoline engine. The diesel fuel tank is differ because in the case of diesel system, you have a filler neck, and again you do not have the evaporative emission control device or charcoal carbon canister device in the case of a diesel engine, whereas you have it for a gasoline engine. And the diesel fuel is drawn from the fuel tank by the lift pump, and it delivers the fuel to the injection pump. And again, between the fuel pump and the fuel tank and the pump, the water fuel separated because it will separate water and the fuel. And water is heavier than the diesel, and it sinks to the bottom of the separator. Basically, this system is used to eliminate the water content. It will separate the water from the fuel. The fuel injection system for a diesel engine consists of two methods. One is air injection method, and one is airless injection method. It's also called a solid injection method. And see, this air injection is using the air compressor. Okay, you need to have a single stage compressor or multi-stage compressor for making the system to inject the fuel. But in the case of solid or airless, you don't use the air injection, the thing, whereas you are using the electronically controlled injection system or mechanically controlled injection system. And in the case of mechanically controlled injection system, you have the pump rail injection system, individual pump system, and distributor system, and you have the electronic fuel injection. So this is the distributor system. So we will see the three types: distributor, pump, individual pump system, and also common rail. Then we will see the electronic fuel injection system also. This is the typical distributor type of diesel injection pump. It is having the fuel pump, fuel lines. These are the lines actually. It's a fuel filter. So here in the case of the distributor type diesel injection, yeah, you are using a injection pump which is used to increase the pressure of the diesel fuel from very low value from the pump to the high pressure which is required for the injection. So as per the thermodynamics law, the pressure moves from low pressure to high pressure, and you see the injection. What you're going to get out of the distributor type injection pump, it increases the pressure of the diesel fuel from the pump from the fuel system, and it will pump where it will increase the pressure from the low level which is there in the pump to the top of the thing which is required for the injection system. Next is again the example is the even in the same distributor pump is the line diagram where you have the fuel tank, fuel pump. Basically, this the lift pump which is lift. This fuel pump is called because it is going to lift the fuel from the tank to the injection system. So you have the fuel filter which will filter the fuel, and so this typical line diagram showing all the components. So then it goes to the fuel injection pump system, fuel injection system, and when the pressure is going to be higher and excess fuel is going to come in this direction, it's a return line basically. And with the help of the fuel injection pump, it goes to the fuel goes to the injector, it will inject. And again, it is basically spring operated one. Even you have a solenoid operated fuel injection pump also. So here, what is important is the case of a distributed diesel system. Uh, it is having in the lines leading to each and the individual injector. Okay, it is having the suppose if it is a 2-cylinder or 3-cylinder, it is having an individual injector for each and every individual cylinder. So here the pressure line is between the injector and the distributor must be the same length to ensure the proper injection timing. So the next important the type is the common type fuel injection system. It is also similar to multi-point fuel injection system what we have seen yesterday. So you have the lift pump which will lift the. It is called as different name actually. You can call it as a lift pump or a transfer pump or a fuel pump. Basically, all the names remain same, and again it does the same work. And it goes to the filter. Then you have the high pressure pump. It goes to the common rail, and the excess fuel comes again to the fuel tank. Basically, in the case of the fuel injection system for a diesel engine, the injection pressure is very much important. So again, it's all based on the sensors. Even yesterday we have seen it's close to loop feedbacks. One where you have the electronically controlled one, where you have the temperature sensor, pressure sensor, crankshaft position sensor, camshaft position sensor, exhaust sensor, even the airflow sensor. So based on that, the fuel gets injected into the system. So higher speed, the quantity of fuel getting injected will be higher. So we will see the operations of the fuel injector. Okay, this is the typical injector. The injector is having different nozzles. This is the nozzle how you inject it. So basically, we have 4 type of nozzles. Uh, I will complete the nozzle type, then I will come to the operations of the fuel injector. Okay, you have 4 type of nozzles. I will complete the nozzle types, then I will come to the operations of the fuel injector. So nozzle is the one where the fuel gets injected. So we have 4 type of nozzle. One is a single hole nozzle, one is a single nozzle, multiple hole nozzle, and a pit-off nozzle. And the pressure varies between the different nozzle. Basically, in the case of single hole, 18 megapascal, and in the case of single hole, it varies between 8 to 10 megapascal. And in the case of multiple hole, it is 18 megapascal. And the fuel gets injected before top dead center. You see the different angles. Okay, even you can go for multiple injection strategies also. You can help this type of the nozzle what you have. First one is the single hole nozzle. The single hole nozzle requires a high injection pressure because you are going to have only single hole here. And this type of nozzle has a tendency to dribble. You dribble, and again there is a possibility you will have some leakage also. Okay, with the help of the single hole nozzle. And even though it looks very simple in design and construction, it has a tendency to basically the leakage can happen. And again, the spray cone angle is usually narrow. The cone angle is nothing but the overall angle from one end to the other end. The spray cone angle is usually narrow in the case of a single hole nozzle type, and it will give a poor mixing unless the velocity is higher, because you need to have high velocity and you need to have high pressure. If it is not having high velocity and high pressure, then the proper mixing of air and fuel is not going to happen, and as a result of that, the complete combustion will not happen. So next one is the pitted hole nozzle. Here, this pitted hole nozzle is been developed to avoid dribbling, so which is there in the case of single pole, and again to avoid weak injection system also. And here, the spindle is provided with a spindle capable of protruding in and out. You have the spindle which will protrude in and out, and again this spindle nozzle will result in good atomization. The atomization is not good here, whereas the good atomization will happen here, and it will also reduce the penetration. And the next important type what you have is a multi-hole nozzle, where the number of holes will vary from 4 numbers to 18 numbers. Again, the number of holes also depends on requirement, and also it will vary with respect to the engine configurations, the peak firing conditions, operating conditions, etc. So in the case of multi-hole, uh, you see, how the spray angle, cone angle gets mapped. Basically, the cone angle will be higher in the case of a multi-hole nozzle. And again, this allows a proper mixing of air and fuel mixture. And but one problem is going for a multi-hole nozzle, there is a possibility go with a rich mode, because you inject the fuel, but that can be controlled with the proper sensing of the sensors. Yes, you can, and again that sensor will give you a direction. What should be the injection pressure? What should be the injection quantity? What should be the duration of the injection? Even that can be avoided. Okay, the advantage what we have in the case of multi-hole is it lies with the ability to distribute the fuel evenly and properly with low air motion within the chamber, okay, within the combustion chamber. And again, the last important type is the Pintax nozzle. It's also similar to the pitted hole nozzle. It is having the auxiliary hole drilled. So you can see the auxiliary hole. You have the auxiliary hole which is drilled into the nozzle, but this is the nozzle body basically. You have the hole at the nozzle body. What happens when the engine is running in low speed? Then you also have the needle valve that does not lift fully, and most of the fuel is injected through this auxiliary hole. Okay, and now we'll see the operations of the fuel injector. It is having different components in it. It is having the nozzle body, it is having the cavity, it is having the valve, stem, cap nut, fuel duct, spindle. This is the spindle, and it is having the holder body. It is having the spring. It is also having the adjusting screw, which will adjust the spring. It is having the lock nut, which will lock the screw, and you have the fuel inlet, and this is the leak of connection. So we'll see how the fuel injector works. Okay. So fuel is injected by a pump. So whatever the fuel is there in the tank, it gets lifted up. Pump is also called as fuel. Fuel pump is also called as transfer pump or lift pump. The pump, what we have, it will exert the sufficient pressure and the forces that lifts the nozzle valve, and you have the valve here. It is a valve. Okay, basically this is called as a nozzle valve. This nozzle valve gets lifted when the pressure is going to be higher. When the pressure exerts higher pressure from the fuel tank through the transfer pump into the system where the fuel comes here. So the pressure is going to be higher here. When the pressure is going to be higher, what happens? It will lift the valve. Basically, this is nothing but a nozzle valve. Okay, once this uh, nozzle valve gets lifted, the spring tension, or you have the spring. Okay, this is a spring. The spring pressure or the spring force. So you call this a spring tension, and the valve operating pressure is again it will vary. Okay, and this is again controlled, the valve operating pressure and the spring pressure or the spring movement, spring displacement, or the tension is been adjusted with the help of the screw. What you have, the adjusting screw here, this gets adjusted with respect to the pressure what you are going to get into the system. Okay, accordingly it will get adjusted, and accordingly it will also control the amount of fuel what you're going to inject into the nozzle. And you see, when the nozzle valve is lifted up, because when the pressure is going to higher, the nozzle valve gets lifted up, uh, the fuel comes in and it gets sprayed into the combustion chamber through this nozzle. So you have four type of nozzle: pintle, pintax, singular, and multi-hole. So mostly we are going with the pintax or pintle hole, but because it is having the high efficiency respect to the atomization, and also the proper mixing is going to happen. Because when you go for a single hole, you have a problem of going with the high injection, which is sometimes very difficult. The velocity should be higher and may not be possible. And when you're going with a multi-hole, again, you need to the multi-hole with the pintle type is also good, but when you're going for a multi-hole alone, you need to control such a way. Otherwise, the quantity of fuel getting injected will be higher. But to avoid that, you have the computer ECU controlled operator one, which will help to inject the fuel in right quantity, and it is also helps for atomization. But the problem is the pressure needs to be higher even in the case of multi-pole also. Um, okay. The last important point here is with respect to the operation of fuel injector. So when the fuel supply is going to be exhausted, what happens? The spring pushes the valve back on its original location. So because of the high pressure, what happens? The valve, the nozzle valve, uh, gets opened up, and it allows the fuel to enter to the nozzle, and it helps for injection system. Basically, it will spray and helps for the combustion. But when the fuel supply is exhausted, when there is no fuel supply here, okay, when there is no fuel supply here, what happens? Pressure is going to be lesser here, and it's not going to be lesser. When there is no supply, there is no pressure here. Okay, which means the wall, basically the nozzle wall, going to remain back to its original position, and it's going to be on its own seat. What is there at the initial stage? So with respect to the fuel spray optimization, so the nozzle design is very much important. Because why this nozzle design is very important? Because this will have influence on the spray pattern, and this will also help for the atomization of the fuel spray penetration, or what should be the penetration of the fuel, and the droplet evaporation and the air field mixing. You see, you have different term. What should be the spray angle? So what is the overall coverage of the spray? That indicates the spray angle, and the spray tip penetration. What is the maximum duration the fuel can travel? Okay. So shorter distance will have the flame traveling distance, the flame traveling distance is lesser. Okay, this is the flame, it travels like this, and if the flame travel distance is lesser, even the combustion rate will be higher. So even this also matters, like, okay, what is the maximum heat it will penetrate, and and again, what is the breakup length? You see, up to this, fuel gets injected, and it again breaks into fine atomic, like droplets. It divides itself into fine, minute droplets, and this is the distribution, how the size gets distributed. So breakup length is the distance from the start of the injection till it gets distributed into various sizes in the form of droplets. So we have different injection pressure and injection timing in the case of diesel engine. So over the period of time, so this is the graph which shows injection pressure versus the particulate matter emission or the carbon particle. So when the injection pressure is going to be higher, what happens? When the injection pressure is going to be higher, the combustion is going to be higher, which means the temperature is going to be higher. When the temperature is higher, what happens? The unburned carbon soot particles gets burned away, which means the particulate matter is going to get reduced. Okay, so that's why you can see from the year 1985 to 2010, particulate matter emission is keep on decreasing as the injection pressure is keep on increasing. When the injection pressure is getting increased from 500 bar, so even now, even the Toyota, some of the company, they use fuel injection pressure up to 2,500 bar. Um, so when the injection pressure is going to be higher, the advantage is that we are going to get less particulate matter. But there are other disadvantages also. When the injection pressure is higher, because you cannot when the particulate matter is going to be lesser, then you get the NOx emission also. So for that, you need to go for the multiple injection strategies. They will explain in this class itself. Even I have given the multiple injection strategies in the first class, but now the same graph, it will be easy for you to understand because you have seen a lot of basics about the fuel engine, about the emission strategies, and again some basics also you have gone about the engines, so it will be easy for you to understand about the injection strategies. Okay, so as I told you, when the particulate matter is going to be lesser, you are going to get higher NOx. So this is the effect of high injection pressure in the case of diesel engine. This is the result taken from the research paper, one of the research paper, which the research was done in an engine with the engine speed of 1,400 RPM and the engine load of 30% as engine load, and they have taken various injection pressure in terms of megapascal. And again, you see, when the injection pressure is going to increase from 70 to 140, the NOx emission is going to get increased. Okay, and there is some decline here, and they are going to do some optimization with terms of the calibration activities. But generally, see the particle matter is going to get decreased, and the NOx is going to get increased. And this is with respect to the different scenario actually. Okay, this is with the 30% load. This is with respect to 80% load. Okay, see when you're taking the 80% load, you can see there is a drastic increase. But you see there is some decrease is going to happen when the load is going to be lesser. And again, the mode is also going to be different. Okay, and what mode you are going to run the test, even that will influence the nitrogen oxide emission. But overall, in short, I can say, irrespective of the operating condition or the parameters, NOx gets increased considering the high injection pressure. When the high injection pressure is there, you are going to get high NOx. Okay, this is the stages of combustion we have seen. The case of a C engine also. You see here, the start of injection, when the fuel gets injected, what happens? The ignition delay is going to happen, or injection delay here. So the ignition, it ignites after some delay period. So when the ignition starts, you get high pressure super. This stage is called this as a premixed combustion stage, where the air and fuel gets premixed. It's not going to be completely mixed. Okay, then the pressure comes down, and again when the air and fuel gets mixed again, you get the high pressure, high heat release. But the heat release, what you are going to get in the mixed control zone, where air and fuel completely mixed, will be less heat release rate, because the air and fuel gets mixed completely. Whereas in the case of pre-mixed combustion, the air and fuel is not completely mixed. Okay, so you have high heat release and high pressure because you have more fuel into that pre-mixed combustion phase. And once it gets completely mixed, you go to the last stage called the lead combustion phase, where it comes to the less pressure or minimum pressure, or it should to be a dead one, where you get zero heat release rate after the lead combustion phase. This is again the data taken from some of the research papers. You have different nozzle types. So it is very important to do the sizing of the nozzle. You need to do the optimization of the nozzle also, because if you do the optimization, you can also control the flow rate of the fuel. M.F is nothing but mass flow rate of the fuel. So how much is the quantity of fuel getting injected in terms of mass flow rate? And that you can control. And we have seen is having the start of injection and end of injection. It is having the start of injection and end of injection. Between this period, when you integrate it, when you integrate you need to design the nozzle considering the area with the area of the nozzle. Okay, area is again pi by 4 d square. D stands for diameter. It depends on the diameter of the nozzle hole. D is nothing but the coefficient of discharge. That is the value, coefficient value, and it's product of again 2 into rho is the density of the not the air here, it's the fuel. Okay, what is the density of the fuel? Okay, what is the density of diesel? And again, when even now you can also go for a different density. If you're even when you're going for a hydrogen injector, means when you're injecting hydrogen instead of a diesel or a gasoline. Okay, so the fluid here is hydrogen. Okay, what is the density of the hydrogen? Okay, accordingly, see, this nozzle configuration or the injector configuration will be same irrespective of the system what you're going to go have. It can be for a diesel, or it can be for a gasoline, or it can be for hydrogen, or it can be for the alternative or other fuels also. Whatever the fuels you're using, you need to put those density value here, and what is the pressure drop you're going to get before and after. So considering this, you need to integrate, and N stands for the speed of the nozzle. Accordingly, the mass flow rate it gets you get the mass flow rate of the fuel. And you see, this is the needle lift. You have the you have the needle valve, which is not highlighted here, I think. Okay, basically the valve is basically the lift kind of thing. Okay, it's nothing but the needle valve also. It's called needle lift, needle valve, or both are same. Okay, when the lift gets increases, okay, basically that you can get the higher lift when the pressure is going to be higher. Okay, when the needle lift gets increased, and again you are going to measure it different values. So when the value is going to get increased, what happens is the nostril bore cross section area, okay, the area is also going to be higher, okay, meaning so when the valve is going, when the needle valve is going to get increased or going to uh, going when it is going because of high pressure, okay, when it is getting lifted up, okay, when it is getting lifted up, what happens is uh, it is allowing the fuel to go to the nozzle, where higher the lift, what happens, you get high amount of fuel into the nozzle, which means you are increasing the area of the nozzle, okay. It's not that you are going to increase the nozzle area, means the quantity of fuel into the nozzle location going to be higher, which means when the quantity is going to be higher, what happens, the area is going to be higher, which means when I'm taking the cross section of the quantity, that is going to be higher. So that is what it is shown here. The area is going to be higher when the needle lift is going to be higher. Okay. So yesterday we have seen the advancement with respect to the gas indirect injection, which is nothing but vaporized fuel injection system. So now, even because of aerodynamically controlled fuel injection system, you have the advanced one, that is the hydraulically actuated one. This is the next generation diesel injection system. It is hydraulically actuated, electronically controlled unit injector. The system remains same, and there is no difference. But here we are also using hydraulically actuated mechanism. So the system remains same. The configuration remains same, where you have the filter, pump, injection controlled, everything remains same. But only advantage what you have here is you have the hydraulically operated sensors system, where you get the high injection pressure. Okay, when the high injection pressure is going to be higher than the normal fuel injection system what you have, um, which is also uh, the, the phenomenon which is controlling the speed of the engine also as well. See here, when you're going for this hydraulic operated one, the injection pressure is going to be higher, which means you get less particulate matter emission also, which means even the hydrocarbon, the unburned hydrocarbon will be left away. There will not be you get less hydrocarbon. Okay, even that is also the advantage what you have. And again, this hydraulic operated thing will also increase the pressure. Okay, this pressure can help you to ensure that the, go for a complete combustion of the fuel. So no fuel will be left away. Even this will help again. And one more advantage what we have with respect to hydraulically actuated thing is you can completely shut down hydraulical operation. If the pressure is whatever the pressure, if it is already there, you don't need to have the the hydraulically operated valve. Okay, you can easily shut down that one, and you can maintain the regular whatever injector what you have. Okay, uh, you don't need to increase the pressure unnecessarily using the hydraulically one if pressure is already maintained into the system. But only problem is during the start of the injection, during the start of the vehicle or during start of the engine, sometimes you need to have some high pressure, which is it may not be possible without hydraulically actuated. So in that case, you can operate it, and when the vehicle is running in high RPM or high speed, you don't need to actuate this one. Even this technology is there, where you can shut down or you can on whenever it's required. So we have seen these multiple injection strategies with respect to the load and with respect to the speed of the engine. So you have different phenomena where you get noise when the engine is running in idle RPM. You get knocks, and you get high torque, peak torque. You get with respect to the different speed, and you get high power and at a higher RPM. Rated power you get at the rated RPM. And you see, this is what we have seen in the multiple injection strategies. This is just a snapshot I have taken from one of the research paper. Um, see, it is not that again. The values will vary. It will vary with respect to different configuration. And just for a theory point of view, I'm taken the snapshot and I'm explaining you. You see here, you need to consider the injection strategies. Okay, again, we have seen the wall timing diagram. So before explaining this multiple injection strategies, what I will do, I will once again explain the wall timing diagram. Then I will explain the multiple injection strategies, so that it will be easy for you to understand. So we will go with the, the injection timing, the wall timing diagram for a four-stroke diesel and a two-stroke diesel. So this is the wall timing diagram we have seen. So the fuel valve opens. See, this is the fuel valve. Fuel valve opens. Uh, 15 degree before TDC. Okay, the fuel valve opens 15 degree before TDC, and the fuel valve closes 25 degree after TDC. See, remember the term 15 degree. Okay, fuel valve opening at 15 degree in the case of a four-stroke. Or it can also vary between 10 to 15 degree also. Okay, this for a four-stroke engine, and for a two-stroke diesel engine, it remains same, almost 15 degree. Okay, so again 15 to 20 degree maximum. Maximum no, not 20 degree. 15 degree before TDC and 20 degree after TDC will be the fuel valve closing. So you can consider on an average of 10 to 15 degree. Okay, that will be the fuel opening degree. So now when I'm going for the multiple injection strategies, okay, what happens is instead of going for a 15 degree, so now I'm going to consider the 15 degree as percentage. Okay, so when I'm injecting the fuel 15 degree before top dead center, that becomes 100 percentage. Okay, uh, see, and what I'm going to do is instead of injecting the fuel 15 degree before top dead center, I'm going to give some delay period. Okay, where for first 2 degree I'm going to inject, then remaining 5 degree I will not inject, remaining 8 degree I will inject. Okay, you are going to give some delay period. When I'm giving this delay period, what happens is the the peak temperature is going to be reduced, which means uh, you have the delay period of mismatch, which means you are not going to inject in so time. And in that case, what happens? You don't have the combustion at that point of time, which means your temperature going to be reduced. It means there is a possibility that your nitrogen oxide can be lesser, but at the same time, your particulate matter will be higher because of this. Okay, because of this configuration, the particulate matter is also called as soot. Okay, the soot is going to be higher because of this. Okay, and you get lesser NOx, however. But even this soot particle can be reduced when you're going for a high injection pressure. Okay, we have seen the high injection pressure. Okay, how we can increase injection pressure we have seen. And when you increase injection pressure, you can reduce this. But again, that's the problem with the NOx. Okay, you need to do the trade-off. That's why we are going for this type of multiple injection. And again, instead of this, what I'm going to give is I'm going to give a delay period. Uh, this delay period is with different percentage. Out of 100 percentage, what I'm going to take. So 15 degree before TDC, I'm going to take as 100 percentage. So 100 percentage is divided into various things like 85 percentage plus 15 percentage. So first 85 percentage, what I'm going to do is that maybe for initial level, I'm going to inject the fuel very minute quantity. Then for remaining percentage, maybe 50 percentage of the time, I'm going to have the main injection. It means where the fuel gets injected in large quantity. And again, I'm going to give a delay period, and I'm going to inject remaining 15 percentage. Okay, 15 percentage with respect to the degree whatever I have told. 15 degree before TTC. So this type of thing will have the reduction with respect to the emissions point of view, and it will have the trade-off. Okay, carbon monoxide, hydrocarbon, NOx, and again even the PSFC also very much important. Okay, with the lesser PSFC will increase the mileage of the vehicle. So you need to do the trade-off in PSFC, soot, NOx. You see that's why most of the things PSV is better here, soot is better here, even NOx to some extent is better, and CO is lesser here. And for the yellow point of view, which is different strategies. Okay, and so but you need to select accordingly. Okay, even this percentage will vary with respect to different configurations. Is an example taken for a capper for a four-cylinder engine, having at a speed of 3,550 RPM, and again this data will vary again with respect to different engine configuration. So why I have taken the snapshot is that you need to understand how you need to go for a multiple injection strategy, how you can adjust the pressure of the system. Okay, and when you're going for hydraulically operated electronic fuel injection system, what happens? You get higher injection pressure, which means still you can reduce the soot, whatever is the here. It means still you can optimize the fuel consumption, but even the high CO can be reduced to further below. But again, to increase, there will be a problem with respect to NOx. But this NOx can be reduced with even after treatment. What we have, there are a lot of after treatment what we have. So ACR technology or LNT. So even you need to go for it. But maximum thing you need to do with respect to the before after treatment. So because you get the CO2 out of after treatment also. The amount how much you are going to reduce CO will have the influence with respect to the output of the CO2 as well. So this is the different multiple injection strategies. See, this is again based on the consolidation what had been taken from the research paper. When you are advancing the fuel injection or when you are retarding it, basically when you are advancing the fuel injection, so instead of 15 degree before TDC, so when you are advancing it to 17 degree, okay, what happens? Your injection pressure going to be higher, which means the NOx going to be higher, and again you get some of the particulate matter is also because you get more fuel. Okay, instead of 15 degree, if you inject at 17 degree, what happens? 2 degree you are injecting it, and again the quantity what you're going to get out of 2 degree is going to be higher, which means your carbon soot particle is going to get, okay, out of the fuel you're going to get the carbon. Okay, it's unburned carbon basically, which comes as a carbon soot particle also. So it's not that because of high increase of NOx you're going to get a reduced particulate matter. And obviously you go to get carbon monoxide and less hydrocarbon, and NOx is also going to be higher, and the fuel consumption is going to be lesser. So again, so when you're having one part getting increased, the other point going to get decreased. And we have seen the exhaust gas recirculation also, where it will reduce the NOx. When you go for EGR with SCR condition, so by this strategy, what we have shown, we can also adjust it. So even when there are different formulas, different strategies we need to use with respect to different combination we can play also. So considering that, we need to get the most effective thing for our system. So even you can increase the rail pressure, and when you increase the rail pressure, your pH pressure gets increased. You're going to get less particulate matter, high NOx, high noise, because you're going to get high noise. Again, when you're increasing the boost pressure of your engine, you're going to get less particulate matter, no influence on the NOx, carbon monoxide, hydrocarbon, and less noise. And your mileage is going to be lesser, fuel consumption will be higher. And the most important thing is that you need to play with respect to the quantity of pilot and main injection. So the way how you are playing will have the influence with respect to the emission norms. But the main objective is that we want to reduce this carbon monoxide. How much you are reducing this? Because you have diesel oxidation catalyst, and you have and after treatment, but finally you are going to get CO2. At any cost, you are going to get the CO2. The amount of CO2 is depending on the CO, how much it is coming out of the system, is for which you need to play a key role. Okay, uh, and even you are going to get the C, you are going to get the C, and even you are going to get the oxygen from the air. So these two is very much important. Okay, um, even when the NOx is reacting with nitrogen, you get ammonia. When it is reacting with ammonia, you get nitrogen and water. But obviously, the CO2 will be there ever coming out of the engine. That how much you are going to reduce the CO2, that is very much important. So we will see the phasing of injector, which is last topic. See, the fuel injection pump phasing is one of the most effective methods to reduce the gear impact noise in the heavy duty diesel engine, basically. And this phasing of injector is a well known one that helps pressurizing the fuel in the injection pump. It requires non uniform torque, contributes to the speed fluctuation of the engine during its operations. So we will see in a detailed one, like and the points with respect to the injector phasing in a diesel engine. Okay, the fuel is injected in phases. Okay, you have different phases for the injector. So I told you you have main injection, pilot injection, and delay period. Even you call that as a delay injection also. It's not the delay period. Even you can call that as a delay injection. Injection getting delayed during that time. See again, this whatever the pilot, main, or delay, it will also vary with respect to the speed and also engine load. And one such phenomenon when you're going for the placing of injector with respect to the under full load condition, it's common to have one main injection only. Okay, when you're going for a full load, okay, and the torque of the engine is higher, then you can have only main injection. Okay, how you are going to do the phasing, that is also very important, because this will have the influence on the emission also, emissions as well as performance. Okay, when the engine is running in cruise condition, okay, uh, you can do with phasing again. This means there are again you have one or more pilot or pre-injections. Then you can have one or more main injections and one or more post injections also. So you need to do the phasing. That's what the phasing can be of a different method. The 100% can be divided by different thing, like here how the research has been done, considering 15 percentage, 50 percentage here, and 35 percentage here. So even the percentage can be varied. Okay, uh, so you need to select the best percentage, and you need to do the phasing such a way. And again, the phasing will also vary with respect to the different condition also. So here, for example, in the case of the engine is running in full load condition, here they consider only the main injection, whereas when the engine is running in cruising condition, uh, they mentioned that need to go for one or more pilot or pre or post injections. So here again, why we are going for this spacing is that it will help for a completely mixed air fuel mixer, and again it will also help for stratifying the charge. Meaning, and automation will be better. Meaning it will be good for the complete combustion inside the cylinder. And by this way of phasing the injector, by adjusting the quantity and the period of the injections, so this will help for maintaining the lean rich mixer or glycometric, and that will help for maintaining the emissions as well as the performance of the engine. And the choice for going for a useful air flow is much more wider when you're going for the fetching. And the compression what you're going to get, it will be a more favorable, and it can be much more better for avoiding the incomplete compression. So again, the other reason why we are going for the injector fetching is that it helps for a globally lean mixture, meaning more air and less fuel. Even the quantity of the fuel needs to be taken according to the air, according to the speed of the vehicle. We can be much more optimized with the help of the spacing. And obviously, you're going to get a good performance and fuel economy out of it. And we are not going to destroy the engine in the process. That is very much important. Okay, you are not going to destroy by injecting more fuel by doing this spacing. Okay, that is not our objective. We're going to optimize it such a way we get the best out of it. Here, I have not taken the other thing. I have taken only the emission. Even you have the performance output also. Uh, maybe I will try to send some of the snaps out of the research paper where you get the different performance with respect to the power and again the torque. So even that also had been compared in this research paper. And the last important point with respect to the facing of injector is that uh, it will help to identify the rich spot around the spark plug can be easily ignited, and the rich spot here indicates high fuel and less air. Identify that, and accordingly, what happens is it the senses, and then it makes towards the lean mixture, and otherwise what happens is it will not ignite from the little spark. So it will also help to turn towards changing the mixture also from rich towards lean. So sometimes the lean is much more better because you get less fuel and more air. So less fuel means uh, it's not that you are going to supply less fuel. You are going to supply the fuel which is required for the combustion according to the speed, according to the operating condition of the engine. So this phasing of injector is very much important, which will determine the performance of the engine and also the emissions. And moreover, people are mostly concentrate on the mileage of the vehicle or the consumption, for which the phasing is very much important. So here the important thing is that uh, placing of the nozzle and then the spray pattern. Okay, how the spray. Okay, what is the depth, and this is also very much important with respect to the fuel injection system. So this is the end of these things.